Hello everyone, welcome to another video of constraints, and in this video we are going to generate this pattern. The first element should be, the zeroth element should be 5, then minus 10, then it should be 15, then minus 20, then it should be uh, 25, then minus 30. So let's begin with our constraint class first. So how many elements are there? So there are a total number of 6 numbers. So we will write, we will just write a random dynamic array, and for that array, we will write a constraint, and that constraint will just limit the size to 6 using the size method. Here we go. So we just limited the size to 6, and the other constraint we are going to write will be for the pattern. So usually my general approach is to divide the elements, if possible, into two parts. The first part will focus on the uh, even elements, those are zeroth, the second element, the fourth element, and then the second part should be the odd element, which are 1 and 3 and 5. And doing that, the things become much more simple. So first I will iterate through each element of the loop, and after doing that, first I will write a condition that will focus on the even elements. So if I, or the iteration variable modulus 2, it's is 0, then of course it is an even element. So if that's the case, then we will just focus on the even elements, and let's try to generate all the patterns. So the very first thing you can observe in the even elements is that the first number is 5, and then it is getting added by 10, and then again by 10. But the most simpler approach, or the way of seeing this pattern, is to recognize that everything inside this is a multiple of 5. So 5 times 1 is 5, and 5 times 2 is 10. Only difference is that the odd elements are of negative sign. So it is a continuation of 5 getting multiplied by 6 times in a row, and for all the consecutive odd elements, the same multiple is in minus, in negative. So it is pretty obvious that um, the element are just the multiple of 5, and they are with respect to the iteration variable. So I will go ahead and write 5 for the first element, just to make it sure that the first element will be 5, of course. Then what is the formula or relation we can write for the iteration variable I that will generate the remainder of the even pattern? Let's find out. So to think of that, we just have to multiply the iteration variable, right? So if we multiply it by I, then it will be a problem because the first even element will be 0 and 5 times 0 will be 0. Then we have to find a way uh, just to make sure that it is following the pattern correctly. And it is very simple. 5 times 1 is 5. So you just have to add 1. And using this, you could generate the first pattern, the first number, 5. So we just get the 0th element as 5. So what about the next element, next even element, which is 2? Let's find out. So in the next element, 2 will be, I will be 2. So it will be something like this, 5 times 2 plus 1. So 5 times 2 plus 1 equals to 5 times 3, which is 15. So yeah, we did get the correct even element, the second element correctly. So let's find out if the same thing happens with the other elements. So the next even element is going to be 4, which is this one. So for 4, let's do the same thing. We will just omit everything for this formula, and it will be 5 times uh, I plus 1, and I this time is 4 and plus 1. So if you will multiply this, this will be 5, and 5 times 5 is 25. So yeah, we did generate the pattern successfully for all the even elements. So now let's do the same for the odd number of elements. Else, so for the odd number of elements, everything is pretty much the same. The only difference is that we are getting negative numbers. So for that, we could just let's find out. So it is a fact that the odd number of elements are also getting multiplied with the iteration variable plus 1. Only difference is that it is minus 5. Minus 5 is getting multiplied right here. And then the remainder of the thing will be same. And if you will observe, we will get the same thing. So, but in negative. So for the first element, we will get 1 plus 1, which is 2, and 2 times minus 5 is 10. For the third element, which is the second odd element, we will get 3 plus 1, which is 4, and 4 times minus 5 is minus 20. And lastly, for the fifth element, we will get 5 plus 1, 6, and 6 times minus 5 is minus 30. So yeah, we are getting the correct elements, the correct pattern for both the even and odd elements. So let's save the code and let's write our display system task inside the post randomize function. And I will use this just to print the elements of the array. And this will happen after the randomization is done. Now we are done with our class. So let's move on to the main module. Let's declare the handle and call it C1. And inside the initial begin, it should be initial, not initial. And inside it, let's assign the object to that handle. And right after this, let's randomize the class using the immediate assertion. Else it will generate an error. Let's save the code and let's check whether we have made any typos or not. Okay, we do have two errors and oh yeah, I got it. I declare this variable as ARR, not A. So in the previous video, I declared the dynamic array as A, so that's why I got confused. And right here also it should be ARR. Okay, this time we don't have any errors, so let's go ahead and run the simulation and let's check whether we have any simulation errors or runtime errors. Okay, let's take a look at our generated pattern. So yeah, we are getting our desired pattern of 5, -10, 15, then followed by -20, 25, and -30. So we already did a brief walkthrough and explanation behind the logic and the algorithm used. So there is nothing left, nothing much left for explanation. But my fundamental approach is to find out the symmetry in the pattern, whether it can be divided into odd number of elements or even number of elements, or it can be divided into two parts, so that it makes the things much easier to perform. So in most of the case, after dividing the elements into odd and even number of elements, I will just um, do everything with the iteration variable divided by 2, so that even for the even number of elements, let's say it is 0, 0, 2, 4, it will become 0, 1, 2, which makes things pretty easy. But here in our case, you could see that even though the odd number of elements have different sign, it was following the same pattern. That is, each of the elements are incrementing multiples of 5. So yeah, That's all for this video. I hope you find this video useful, and yeah, stay tuned for more.